when we're looking at sine and cosine functions and transforming them, it's basically like transforming any other function. This at the bottom is the transformational form for any function that we did in the first unit of transformations. Y equals a f of b x minus h plus k. And so if you can remember that and how this works, then the sine and cosine are going to be really easy. What does the a represent here in transformational form? The vertical stretch. So it also causes a vertical stretch in the sine and cosine functions, but we're going to call it a different name. But really it does the same thing. It stretches it vertically by that factor. What about the b? What does that do? It stretches it horizontally. H, horizontal translation, and K, vertical translation. So I'm going to talk about the A, B, C, and D that we see here in the sine and cosine function, and we'll see how they compare to those. It's basically the same thing, but we think about it a little bit differently when we're talking about trig functions. When we talk about that A parameter, so it's when we say y equals a sine x or a cosine x, we're talking about the A parameter, and you know that that causes a vertical stretch. But in terms of the sinusoidal function, the value of A is equal to the amplitude of the graph. And if you remember from yesterday, the amplitude is half the distance between the maximum and minimum. So it's from the middle of the graph up or the middle of the graph down. Just y equals sine x has an amplitude of 1. And so then when you stretch it by a factor of A, the amplitude becomes A. So rather than just saying it's stretched by a factor of A, we talk about the amplitude, because that's one of those features of a sine or cosine graph that's important. So this one here in red is y equals 2 sine x, and you can see that the amplitude is 2. If you go from the middle to the maximum, that's 2 units. Or it's half the distance between the maximum and minimum. So you can do maximum, subtract minimum, and then divide by 2. Or minimum, subtract maximum, divided by 2. You're doing the absolute value, so it's not going to be negative. So it doesn't really matter which one you subtract. But if we did negative 2, subtract 2, that's negative 4, divide by 2, and you get negative 2, but we just call it 2. And then the second one there is y equals 2/3 sine x. That's the blue one. And you can see that the amplitude is 2/3. From 0 up to the top is 2/3 of a unit. So rather than talking about a vertical stretch factor, we're just going to talk about amplitude. The b parameter, so that's the value that's in front of the x or in front of the theta. That causes the graph to be stretched horizontally. But the feature that's important when we look at horizontal stretches is the period of the function. The period is that horizontal distance that it takes before the graph starts to repeat itself. And for just y equals cosine x, since we're looking at cosine, but same for y equals sine x, that's equal to 2 pi. But for this one, cosine 2 theta, if we look at the graph here, going from there to the next maximum, it's only pi. So the period of that is pi. And the way that we figure out what the period is from the equation is that the period is equal to 2 pi divided by b. So in this case, for this one, period equals 2 pi divided by 2, which is just pi. And that's why you see it going from 0 as a maximum to pi as the next maximum. That's one complete cycle. So you find the period by doing 2 pi divided by b. That seems to be the one that people have the most trouble with, is period, because a lot of people will think that just b is the period. B is not the period. It tells you what the period is. It's 2 pi divided by that value. B is the horizontal stretch factor. But what we care about here is the period. So for the next one there, cosine of 2/3 theta, what's the period going to be? Let's see. Period equals 2 pi divided by 2/3, which is equal to, what's that equal to? 3 pi. You could think of it like this: 2 pi divided by 2/3 is the same as 2 pi multiplied by 3/2. So then it's, well, I would cancel the 2's, and then it's just pi times 3 pi. So the period of this blue one is 3 pi. If we find a spot that we can use as a starting spot, and from what I'm seeing, I'm going to use minimum because I can see both minimums. From here all the way over to here, that's a different distance of 3 pi. So that would be, let's see, 1 pi, 2 pi, 3 pi. Next one that we're going to look at is the C parameter. The C value is equal to the phase shift. And if you remember, that's the number that's subtracted from the x or the theta. We usually call it a horizontal translation. But the thing about a sine or a cosine function is that it's cyclical. It keeps going over and over, doing the same thing over again. So when you talk about a horizontal translation, it doesn't really make sense because it's infinite. So you can't really translate it. So we say we shift the phase, and that's just basically the period. So we're taking, when we talk about phase shift, we're kind of taking one section of it and looking at how did that move over, rather than the whole graph, just because it doesn't really make sense with the way that it repeats itself infinitely in both directions. So it's still, you can still think of it as the horizontal translation, but we call it a phase shift. So if we look at the first one here, y equals sine x minus pi, means that it's been shifted over pi units to the right. And if we think about what y equals sine x originally looked like, it looked like, it goes through 0, 0. It looked like this red line, sort of, more or less. You can see if you pick one section of it, say one maximum to the next, you can see that it's moved over pi units to the right. Or actually, this is a good point to look at here. That point is shifted over to there, pi units to the right. So pick either a maximum or a minimum or that central point to see how far over has it moved from what it originally was.
Could it not also be reflected?
It could be. Not with the way that the... So the question was, could it not also be a reflection? It looks like it's reflected in the x-axis or the y-axis actually, right? So it could be either of those. But the way that this equation is written, because you're given the equation, you can't say that it's a reflection. But if you were given the graph with no equation, you could say that it's a reflection. Does that make sense? Yeah. Okay. You could also have said, if you didn't have an equation, like another equivalent graph would be x plus pi. X plus, not plus pi. Oh, we shifted 2 pi, right? You could have said it shifted to the left. We said that it shifted to the right because of the equation that we were given. But when you're given a function and asked to write the equation, and you don't have the equation, there are going to be multiple correct answers. Actually, an infinite number of correct answers. But we'll talk about that later. The other one here, y equals sine x plus pi over 4, means that it shifted pi over 4 units to the left. So again, the point that I'm going to look at is this one here. Originally, the sine function is increasing through 0. That increasing has moved over here, pi over 4 to the left. So the last parameter is that D. parameter, which we call a vertical translation when we're talking about any other function, but we call this a vertical displacement, and I don't really have a good reason. I don't know why we don't just call it a vertical translation, but we call it a vertical displacement. But it's the same thing as a vertical translation. So y equals cosine x plus 2, takes the original cosine function, moves it up 2 units. Y equals cosine x minus 3, takes the original cosine function and moves it down 3 units. When we're doing those, we're kind of looking at where that central axis moved to. So originally, the cosine function is centered around the x-axis, like here. Now it's centered around 2. We don't want to look at kind of where the maximum or minimum moved to, because if there was a stretch, then that has to factor in as well. So we always look at where did that central axis move to. It was originally here along the x-axis, and now it's along 2. Over here, it was originally along the x-axis, and now it's here at -3. So that's what we're looking at, where is the central axis when we're talking about a vertical displacement.